Physics. Here in the new semester, we're now working with electricity. And one of the lessons that I thought might be helpful is to get a good working knowledge of series and parallel circuits. So video number 1 today is going to be on series circuits. Okay, first of all, a series circuit looks a little bit like this, as you remember from class. We've got the battery here, and then we have wires connecting a group of resistors or some type of load that provides a resistance in the circuit. One of the key characteristics of a series circuit is that it has a single loop. It has only one pathway for the electrons to pass through. Now, let's put some values in here. We've got a 6-volt battery, this being the positive side, this being the negative side. And using conventional current, we're going to say that the electrons are going to flow from positive to negative. So technically, the electrons are flowing out of the circuit and traveling in this direction. And they're going to go through this first resistor, and then they're going to come on down here and all the way back until it enters the negative end of the battery. Now let's put some numbers on the resistors. Let's say that this one is 4 ohms, and this is 8 ohms, and this is 12 ohms. Each of these being a resistance to the flow of the electrons. So one of the rules that you're supposed to remember is called Ohm's law. And so to go back to some things we should know, Ohm's law is the mathematical relationship between current and resistance and voltage. And it's written algebraically like this. It's I over 1 equals V over R. Okay? Another thing that's important for us to know is that the total resistance is equal to the sum of all the resistances in the circuit. So another way of writing that would be R1 plus R2 plus R3 ... however many resistances are present. Now, another thing that's important about a series circuit is that the current should be the same everywhere. And what that really means is that no matter where you measure the current, it should be the same. So if I measure the current here, I measure the current here, or I measure the current here, the current flow should be the same in the series circuit. And last but not least, the voltage drops should also add up to the total voltage. And we'll explain that a little bit more in just a second. Okay? So first of all, let's go through and let's figure out what the total resistance is. And all we do is add them up. So 4 and 8 is 12, and 12 is 24. So we would write down or record somewhere that our total is 24 ohms. Now, if we know what the voltage in the battery is and we know the total resistance, then we should be able to go back to Ohm's law and substitute in our values, and we see that you got 6 volts and you have 24 ohms. So if you do that math, you'll see that I should equal 0.25 amps. and A is the abbreviation for amps. Now, that's as simple, or that's as hard as they get. Now, to measure, like in the lab that you have to do this weekend, one of the things that they ask you to do sometimes is to measure the voltage drop. Well, the voltage drop has a formula, but you can also use the multimeter to figure it out. So you set your multimeter on voltage. You know that it can't be more than 6, so we're going to set it on 20. And then you take your multimeter and you put the red and black test lead on either side of the resistance. And by doing that, the meter will read the voltage drop. So you've got a voltage drop here, and you've got a voltage drop here, and you got a voltage drop here. Those 3 voltage drops should add up to the total voltage in the battery. There's also a way to calculate for it, and the calculation says that the V drop, or the voltage drop, is equal to the current, which we now know, times the resistor. And I'm going to just put R1 because we're going to use that as an example. If we have I times R1, then I is 0.25 amps times 4 ohms equals 1 volt. So right here, there is a 1 volt drop. We come over to the next side, we've got 0.25 times 8, which is going to be 2 volts, and then we bring it over here and solve for the voltage drop here. That would be 0.25 times 12, which is 3 volts. And so you can see 1 plus 2 is 3 and 3 is 6. Those voltage drops add up to the voltage in the battery. Now, there's one last thing that I know on the lab that you're going to have to do, and that is you have to measure the current. We've calculated for the current, but then if we're going to measure it to see whether it really comes out like it's supposed to, on that PHET lab, there is a tool over in the toolbar called an ammeter. An ammeter is a meter that measures amps. And the way that that works is that you would have to disconnect right here in your circuit, and you would put in that ammeter, connecting it here and connecting it here, and then in the little window of the ammeter, let me write that right here, ammeter. In the window of the ammeter, it should tell you what the current flow is in that part of the circuit. And like we said before, it should be the same everywhere. So we could have put the ammeter here, we could have put it here, we could have put it at any of the other places in the circuit. Now, if you have any questions about that, please shoot me an email and we'll try to clear it up. Otherwise, I'll see you on Tuesday. Thanks for watching.